Mr. Trutna here. This is Math 2 from Clovis High School, and what we're going to be doing on this worksheet, at least on this side of the worksheet, is we're going to be determining whether or not each one of these four ordered pairs are a solution to the given equation. So how we do this is, the process is this. Notice that each equation has a y, a variable y, and it also has a variable of x. And then of course an ordered pair, by definition of ordered pair, an ordered pair always goes in the order of x and y. So what we're going to do is we're going to take the x value, which in this first example would be 0, and we're going to substitute it in the place of x into my equation. Then we're going to take the y value, which in my first example is 1, and we're going to substitute it into the equation. So when I substitute 1 in the place of y and 0 in the place of x, I get 1 is equal to 2 times 0 to the second power plus 1. And then what I do is I evaluate each side of the equation. And then I see if, after I evaluate, if what I get is a true or a false statement. Okay, so the left side of the equation, I cannot evaluate it. It's already evaluated. It's 1. The right side of the equation, the first thing I'm going to do is the exponents. Remember, we always are going to follow the order of operations. So I'm going to go 0 to the second power, which is 0. So that makes my equation 2 times 0 plus 1. Then, after that, I'm going to multiply the 2 times the 0, which is 0. So I'm going to get 0 plus 1. And then I'm going to add those up, and I get 1. So you could see that the left side of the equation, which was already 1, and the right side of the equation, which becomes 1 after evaluate, they're the same thing. Okay, so the instructions say if the ordered pair is a solution, write yes. If it's not a solution, write no. So for this one right here, 0, 1 would be yes. Okay, and I'm just going to go through and I'm going to do that same process for each one of the pairs of ordered pairs. Okay, and what I'm going to do is I'm not going to do every one in every problem. I'm just going to do the first two ordered pairs. All right, so in the second example right here, the y value is 17, so I'm going to substitute the 17 in the place of y. In the place of x, I'm going to substitute the 3. So I'm going to get 17 is equal to 2 times 3 to the second power plus 1. And then what I do is I evaluate each side of the equation. The left side of the equation, I can't evaluate it. It's already been evaluated. It's 17. The right side of the equation, I'm going to evaluate. I have to do the exponents first. Order of operations says exponents before multiply, so 3 to the second power is 9. So now my right side of my equation becomes 2 times 9 plus 1. The next thing I do is I multiply the 2 times the 9. So now my equation becomes 18 plus 1. So that becomes 19. The left side of the equation was 17. So we get 17. That's not equal to 19. So this is telling me that no, 317 is not a solution to the equation. So that one would be no. Okay, moving on to number 2, just to give you an example of how to do it when we have a different equation. So if you notice in number 2, my y is here and I have an x which is here. So it's in the same format as number 1. I just have a different coefficient and a different constant number at the end. But I'm going to follow the same idea. So to see if the ordered pair 343 is a solution for this equation, in the place of y I'm going to substitute a 43. In the place of x, I'm going to substitute a 3, so that my right side of my equation is going to become 5 times 3 to the second power minus 3, and then I'm going to evaluate both sides of the equation. 43 has already been evaluated, okay, but I'm going to evaluate this side over here. Do the exponent first. 3 to the second power is 9, so we get 5 times 9 minus 3, and then I go 5 times 9, multiply those together, that's 45. 45 minus 3 is 42. So you can see we get 43, and that's not equal to 42. So this tells me that the ordered pair 343 is no, it is not a solution. Okay, checking to see if negative 2, positive 17 is a solution. In the place of y, I'm going to substitute a 17. I'm going to get equals. In the place of x, I'm going to substitute a negative 2. So I'm going to get 17 equals 5 times negative 2 to the second power minus 3. Then I'm going to evaluate both sides of the equation and see if they come out to be equal or not equal. Well, the left side of the equation is already evaluated. To evaluate the right side of the equation, I'm going to square the negative 2 first. So negative 2 to the second power is positive 4. Then I'm going to multiply the 5 times the 4. That's 20 minus 3. And then I subtract, and my right side is 17. And if you notice, my left side is 17. So I get the same value on both sides. So this tells me that negative 217 is going to be a solution. Number 3. So in number 3, my equation is y equals, so here's my y value, is equal to the quantity x plus 2 squared. Quantity squared. So when I'm going to determine if these ordered pairs are solutions. So the first ordered pair is 0, 0. In the place of y, I'm going to substitute a 0. I'm going to put an equal sign. Then I'm going to go parentheses. In the place of x, I'm going to substitute the x value, which is also 0 in this case, plus 2. I'm going to close the parentheses to the second power. And then I'm going to follow the same format as the previous problem. So I'm going to evaluate both sides. The right side's the only side that I can evaluate. I always, remember, order of operations, work out the inside the parentheses first. So 0 plus 2 makes this parentheses a 2. And then I have to the second power, which is 4. So when I evaluate, I get 0 is equal to 4. Well, they're not equal, so that tells me that 0, 0 is no. It is not a solution. That ordered pair is not a solution to this equation. Checking to see if 1, 9 is a solution. In the place of y, I'm going to substitute the number 9 equals parentheses. In the place of x, I'm substituting a 1. So I get 1 plus 2, close the parentheses to the second power. Then I evaluate both sides. 9's already evaluated. Can't do anything with the left side of my equation. The right side of the equation, I'm going to follow the order of operations. Work out the inside the parentheses first. 1 plus 2 is 3. So my parentheses turns out to be 3 to the second power. That is 9. And you can see I get 9 on the left. I get 9 on the right. Well, those are equal. So that tells me that the ordered pair 1, 6 is a solution. All right, the last two that we're going to do here is number 4. So I have my equation, y equals negative, then quantity, x squared minus 5. Close the quantity. So here's my y, here's my x. So what I'm going to do to determine if the ordered pair 2, 1 is a solution, I'm going to substitute 1 in the place of y. So I'm going to get 1 equals, and then I'm going to have a negative sign, of parentheses. In the place of x, I'm going to substitute a 2. So I'm going to get 2 to the second power, and then I'm going to get minus 5. Okay, so to evaluate this, the left side of the equation, notice it's already evaluated, it's 1, and I'm going to evaluate the right side of the equation. So I have to work out the parentheses first. Now inside the parentheses, I have an exponent. I also have a subtraction sign. So we always do the exponent first. So the 2 to the second power makes that 4, and then I have a negative, then a parentheses, 4 minus 5, close the parentheses. Still have to work out the parentheses first. I have to shorten this. 4 minus 5 is negative 1. So now I get a negative, and then I have a negative 1. Well, that gives me a double negative. A double negative means I have positive 1. You can see my left side of my equation is also positive 1. So that tells me that the ordered pair 2, 1, yes, it is a solution to this equation. Following along the same lines for the ordered pair 3, 16, I'm going to substitute 16 in the place of y equals, then I have a negative sign. Then I have a quantity, parentheses, in the place of x, I'm going to substitute a positive 3. So I'm going to have 3 squared minus 5, and I close the parentheses. So when I evaluate this, I'm going to evaluate the inside of the parentheses first. Okay, and inside of the parentheses, I have to do the exponents first. So 3 to the second power is 9. So my parentheses becomes 9 minus 5. Working out the parentheses, 9 minus 5 is 4. So now I have a negative, and now I have a 4 inside the parentheses, and that's just negative 4. All right, and then you can see the left side of my equation is positive 16. Well, those are not equal, so that tells me that 316 is no. That ordered pair is not a solution to the equation. All right, I'll do one more here that involves negative numbers, just so we see how it works here. So in this one, I'm going to substitute negative 36 in the place of y. So I'm going to get negative 36 equals, then I have a negative sign, then I have a parentheses, and in the place of x, I'm going to substitute a negative 1. And I'm going to put that negative 1 in parentheses to the second power minus 5, close the parentheses. Okay, now the reason why, now when we evaluate this equation, the right side of the equation, the left side is going to be negative 36. The reason why I put negative 1 inside parentheses is because I have to square it. So negative 1 to the second power becomes positive 1. So evaluating, I get a negative, then a parentheses, positive 1 minus 5. Still simplifying the inside of the parentheses, I'm going to get a negative, and then 1 minus 5 is negative 4. And once again here I have my double negative, so that makes the right side of my equation positive 4. My left side of my equation is negative 36. Well, those results are not equal, so that means the ordered pair negative 1, negative 36 is not a solution.